So this is a very interesting type of problem like that involve numbers. So this is what we normally call this a maximum product problem. So what it says that it is given that the sum of the two numbers is 20. So you have two numbers, when you add them, you get 20. It doesn't say whether those numbers are positive or negative. And then it says that find the maximum possible product, possible product that can be reached by these two numbers. So if you know the sum is 20, what is the possible maximum product that you can have? And also asking, can there be a minimum product? So it's like a very interesting problem, and let's see how we're going to solve a problem like that. So first you notice that since the sum is 20, and then also you are looking for the maximum possible product, those two numbers cannot have opposite sign, because if they have opposite sign you can see the product is negative. So that means either both should be positive or both should be negative. But if both are negative, you can see that sum cannot be 20. If both negative, when you add them you get a negative number. So that means either those numbers has to be either positive or zero to get a possible largest product. And then also it doesn't need to be integers or anything, it can be any numbers. Okay, so now let's see how we set up the problem. So we're going to say let this is a very important step, let x and y be the numbers with you can say x positive and y positive. Okay, so we're going to pick two positive numbers. So then what we can do, we can write the so you can say then you can write the sum, because we know that the sum is 20. So that means this is the constraint. So we're going to put this constraint into an equation now. So into a equation with variables. So you can, the sum is 20. So that means you can say x plus y equal 20. So that's what you get. So you put the constraint first. So that's the first part. You put the constraint into an equation. Now let's try to look at the objective function. So the objective function in this case is the product. So we can write the product, which is, let's call it p. P would be the best value, which is x times y, because you're going to multiply two numbers. And you notice that this is a two variable function. There are two variables. So when you have two variables, you really don't know how to find the maximum or minimum value for function like that in calculus 1. Those are like a calculus 2 topic. So what we're going to do, we're going to bring this to one variable. How we do it? We're going to solve for one variable. So what I'm going to do, I'm going to solve for y first. So you can say y equal, if you subtract x from both sides, is 20 minus x. Now what I'm going to do, I'm going to substitute that here. So you can say x, y equal 20 minus x. So it's a 20 minus x. And then we're going to simplify this one. So when you simplify, you're going to get 20x minus x squared. And then you see that this is a one variable function. That's exactly what we need. So one variable function. Now what we're going to do, let's write the problem now. So you can say maximize p, you can say px now, because of one variable. We just exaggerate the writing px. 20x minus x squared on what interval? You can see that those numbers can be negative, so the smallest can be 0. And what is the largest can be? And you can see that you can have like a number like more than 20. If you have like let's say 21, then to get the sum 20, you will need to have a negative number. So that means you can have more than numbers which is more than 20. So the maximum can be x can reach is 20. So that is the optimization problem. So we set up the problem. So that is the problem actually we're trying to solve. That's the first part. The second part is we can use calculus to solve the problem. So let's do that now. So we can use calculus to optimize the problem. So when you try to use calculus to optimize the problem, and you know that like if you get like a function like that, and you know that so the maximum can happen at either at the critical point or at the end point. So these are what we normally call local. These are what we normally call absolute. Actually, endpoints, not the absolute. We don't know whether it's absolute or not. It's like endpoint. So it can happen at any of those points. So what we normally do, we're going to look at the critical points. So find the critical points next. So to find the critical points, what we do, we look at the function and take the derivative. So we have px equal 20x minus x squared. So if you take the derivative, you can see that you're going to get 20 minus 2x. Now what we do, we're going to set this equal to 0, because you know that the local maximum or minimum can happen at the critical point. So this is like a set. You don't get this, you set this. It's very important. Now we can solve this. So this is very easy to solve. So you're going to say so 20 minus 2x and then divide by 2, so you get 10 equal x, or x equal 10. So that's the critical point. So we have the critical point which is x equal 10. Now we are not done yet, because we want to make sure that you get the maximum minimum value. So what we normally do, if you get like a function like easy like that, we can use a second derivative test. It's very easy to use. So we can use a second derivative test to check whether you get a maximum or minimum. Remember, you need to use that step, because just getting a critical point doesn't mean anything, because it can be a maximum, it can be a minimum, and so we really don't know. But we also know that there's only one critical point. That means the maximum or minimum should happen at this point. So that means you do not have a because there are no more critical points, so you don't have this situation, you don't have that. So that means you cannot have this part as well. There's no branch like that. That means whatever the critical point that you get is should be the extreme value, but still we don't know whether it's a maximum or minimum. We know that that should be the extreme value, that should be the maximum minimum, but we still don't know whether maximum or minimum. So what we do, we can use a secondary test to justify that. Okay, so this is a justification part. To justify what we can do, we look at the second derivative. So when you look at the second derivative, you get what do you get? You get -2. So that means even at the critical point, because you want to look at the second derivative at the critical point. Since this is true for, this is -2 for any, even for 10 you get that. So that means which is negative. This implies that by the second derivative test, you will see that there's a, so has a maximum, So if you forgot the theory about that, you can look at the theory part, and why how you know that. Okay, the secondary test. So it's so secondary test says that because of the negative sign, there's a maximum. That means now we know for sure there's a absolute maximum. So you can say, so then and then also what we need to do is, so we know there's a maximum at 10. Then what we need to do is we're going to find the corresponding y value. So then y equal you get 20 minus x. So in this case 20 minus 10, so you get 10. So 10 is the corresponding y value. Now we know the x value and the y value, so we can write the maximum product. So that means, so the maximum product is, you can see 10 times 10, which is 100. So 100 is the maximum possible product that can happen when x equal 10 and y equal 10. Good. Okay, so that's how we'll kind of do the problem. So it's not that difficult. Okay, let's try to answer the next part. So the second part of the problem is asking, can there be a minimum product for the two numbers? So asking whether there is like a minimum product that can happen. So the short answer is no. This is how you see it, because you can see that you can pick a very large positive number and another negative number, so that the sum is 20 and the product is really large negative. So this is how we see it. So we can say pick x which is greater than 20, and you can see that then if you look at the number 20 minus x, then is negative. So you can see this is a negative number, because x is bigger than 20. And you also notice that if you add the two numbers, x and 20 minus a, those are two numbers, you can see it's going to add up to 20, because x is going to cancel out. So you can add up to 20, and the product, so you can see of the two numbers, x and 20 minus x, is negative. It's negative because the reason is the first number is positive and the second number is negative, so the product is negative. And also see that there can be a large negative number. can be a large negative number when x is large. So that means you can see that there's no limit for that. It can be really like it can be negative 20, negative 2000, negative 1 million, I mean any big number. So that means you can see that there's no minimum product for this one. It can be any large negative number. This is how you solve the problem.